Hello Year 12 and welcome to the fourth video here for our seventh topic. We are looking at offset and radial surveys here, and we need to move quickly because there's quite a lot of calculations and all this. Not terribly hard, but kind of lengthy. So, we're talking about measuring parts of the Earth's surface, and in particular we're going to be looking at calculating perimeter and area. First of all, we're going to look at an offset survey. What we do is we get some shape like this, right? Some sort of shape like this. I lay a tape measure out along the longest diagonal. It might be here. And then I measure the perpendicular distance from that tape measure to each of the other corners. So that's going to be like this distance here, and this distance here. Right, so that they're all perpendicular distances. Okay, collecting that information there will break my area up into a series of triangles and trapezia. And I can fairly well do calculations with those sorts of things. So let's quickly try to scrub that out and move along to an example. Here we go. I've got a diagram here. You can see all of the relevant points have been labelled with a letter. That will help out. And the distances between each of those letters has been provided. So first of all, calculate the area of the field. Correct two significant figures. Well, we've got some work to do here. Let's have a look at the triangles first. Okay, P, U, Q. Let's do this one first. P, U, Q. Quite a good idea to redraw each section here so you can label it so you don't make a mistake. All right, helps with your working. Now, the area of a right-angled triangle is half the base times the height. So in this case, I'm going to call this area 1. Area 1 is equal to half times 26 times 21. Thank you, calculator. Oops. Half 0.5 times 26 times 21 equals 273 square meters. Oops. Yep. Was it 207? No, 273, I think. 273, my apologies for all of that mucking around there. 273 square meters is my first area. Now, let's look at SWR. That's not a bad one as well. Looks like this. Right angle in here. SW and R. I've got a 12 and a 30 there. We call this area 2, and area 2 equals half times 30 times 12, which is 180 square meters. Right, 6 times 30, 6 30s are 18. So that's area 2. Now I'm going to look at this triangle here. Not a right angle triangle, but I do have the information that I need. Now that's 26. There's P, there's T, and there's S. Now, PS is going to be my base. My perpendicular height is 26. I do need to know the length of the base. Well, that's 12 plus 27 is 12 plus 27 is 39. Plus 6 is 45. Plus 21 is 66. Right, so this is going to be my area 3. So area 3 is half times 66 times 26. I've got a perpendicular height, not a right angle triangle, but I've got a perpendicular height. I could use two triangles, but it's just faster this way. Now this one here, 0.5 times 66 times 26 equals 858. 858 square meters. Right, so that's this part done. This one and this one. I've still got this trapezium. So let's draw that one out. I think I'm going to need this later on, so make it a good size. They're right angles there. My labels. R here, W here, Q and U. Okay, now this one is 36. UQ is 36. WR is 30. and UW is 6 plus 27 equals 33 meters that way. All right, this is going to be area 4. Now, this area 4, equals area of a trapezium. Personally, I find the best way to remember this, there's all sorts of different formulas that all do the same thing. The average of the two parallel sides multiplied by the distance between them. So the average of the two parallel sides, that's 36 plus 30 over 2, and multiply that by the distance between them, that's my 33. Right. Once again, thank you, trusty calculator. All clear, and I'll say 33 outside of 33 outside of fraction 36 plus 30 over 2 equals 1,089 square meters. Right. So finally, my area is equal to the sum of each of those smaller ones. That's 273 plus 180 plus 858 plus 1,089. Right, my area is... I have to move my calculator out of the road here. I've got my 1089 plus 858 plus 180 plus 273, and I get 2,400. That's a neat number, isn't it? 2,400 square meters, just under a quarter of a hectare. Right, that was part A. You can see we're already at 7 minutes. B, calculate the length of QR correct to the nearest meter. That was part A. B, QR. Now, fortunately, I've got a nice diagram here. What I'm going to do is dissect this into a right angle triangle and a rectangle. Right? That means I can transfer that 33 over to here, 33. And this 36, you know what, I'm actually going to rub that out. I'm going to say I've got 30 here to here, and 6 here to here. Rightio. So now that gives me a right angle triangle, 6 and 33. 6, 33, I'm going to call that X. It was QR, was it? That's what we've been asked to find, right? So, 3 sides, right angle triangle, Pythagoras' theorem. X squared is 33 squared plus 6 squared. Right, so X squared equals, hey, come on, 33 squared plus 6 squared is 1125, 1,125, and then X is the square root of that, square root of 1125. Back here, square root of my answer is 33.5 meters long. Right, to 1 decimal place. That all good? Now, for part C, find the perimeter of the field. Well, I've only just got this one here. That was 33.5. Now I need to find the other ones there, and this will take a while, and I'm going to skip past it. 21 squared plus 36 squared, square root of that. Now remember that this side here is 27 squared plus 26 squared is the square of this side. 26 squared plus 27, 12, 39 squared will give me this side here. 12 squared plus 30 squared gives me this side here. Do those 4 other calculations. Add them onto our 33.5, gives you the perimeter of the field. Now I want to move on because we do need to talk about radial surveys as well, and there's quite a lot to be done here. Now in some ways radial surveys are a bit more efficient, certainly from a surveyor's point of view, I can tell you, a bit more accurate. What you're going to do is set up in the middle, somewhere where you can see all of the other corners, where you can see all the corners, set up in the middle where I can see all the corners, and from that point I'll measure the distance and the bearing to each of the corners. Now, knowing the bearings, I can find the angles between those legs from the centre to the corner by subtracting one bearing from the other. Mostly, I can do that. That's good. That gives me the angle between these sides, and in fact, that's going to be the angle included between two sides of a triangle, right? And two sides and the included angle is the information that I need both for the cosine rule to find the third side, which we'd use for the perimeter, and the area of a triangle, which is half AB sine C. So here's a diagram. Calculate the size of each of the four angles that meet at P. As I said, we only need to, mostly, subtract the bearings. So let's start with this one in here. 87 minus 20. 87 minus 20, it doesn't hurt to write down your calculations. 67 degrees, okay? 67 degrees in there. Next up, 205 minus 87. 205 minus 87 equals 118. Right. Next up, 205, 300. 300 minus 205 equals 95 degrees. So on there. Now my last one. It's not 300 minus 20. Right? It's more like, think of this as 380. I've gone past 360. It's more like 380 minus 300 gives me 80 in there. But another option would be add the others together. 67, 118 is 185, and 190, 280. They've all got to add up to 360. Right, so once I subtract the others, that gives me 80 there as well. Right, that's the tricky one because one of the legs is sort of to the left of the north arrow, and the other leg is to the right of it. Okay. Nonetheless, two different methods for calculating those angles. It's a good start. Hence, calculate the area of the field. What do they mean by that? We can use half AB sine C. So my area equals half times, I'm going to say 40 by 44 times sine 67 plus half by 44 by 56 by sine 118, right? That's this area here, then this area here, and we'll keep going, plus half times 56 times 37 by sine 95, and also need a plus half by 37 by 40 by sine 80. Okay. Now this becomes pretty messy. You can see that's quite a long calculation. I could, as we did in the previous question, break them up into 4 different areas and calculate them one at a time. But let's just see if we can do this on our calculator. 0.5 by 44 by 56. Oh, all clear. Right, 0.5 times 40 times 44 times the sine of 67. Right. Close the bracket, plus 0.5 times 44 by 56. Bit and go equals, right, 3,659. 59 square meters. Right, yeah, slightly bigger than the previous one. Right, that's A, that's B. Done. Big long calculation. Do it in 4 lots if it makes it easier. Just be really careful about typing everything in exactly as it should be. But that's 4 applications of the area of a triangle. Finally, the length of MN. Let's just draw this up again. I've got a 44, 118 degrees, 56 here. And I want MN. I'm going to call that one X this time. Now, I have a non-right angle triangle. No SOHCAHTOA, no Pythagoras. Non-right angle triangle. But I do have 2 sides in the included angle. And I want to find the third side. Right? One angle, cosine rule. So x squared is 56 squared plus 44 squared minus 2 times 56 times 44 times the cos of my 118 degrees, x squared, right out calculator, here we go again, 56 squared plus 44 squared minus 2 times 56 times 44 times the sine, cos 118 degrees equals, right, 786-ish. X is the square root of that. Right, remember the square root of that. Previous answer. Don't round it off and then type in the rounded off answer. And that's about 86. There we go. Rightio. That's offset and radial surveys. I know we've moved through it pretty quickly. There's lots of little things to do in these questions. They're quite reliable. If something doesn't make sense, and it might not, we've rushed through this a bit, but 16 minutes is quite long enough. If you've got any questions, jot them down. Ask me in class. Cheers.